Okay, so here is an intro to equilibrium. This is actually a quiz I gave my students this past week. So I thought it might be helpful to see what you can expect. And all the quizzes I give are old diploma questions, so something you can see. So here's an old diploma question, and there's all this information about penicillin, but then it is really just asking in this if you know the definition of equilibrium, because it's talking about the system is at equilibrium when the rate of formation of the ion Pn, which is here, in the forward reaction is. And this is all about being equal to the rate of formation of the reverse reaction. So the rate of the forward has to equal the rate of the reverse, and that is the definition of equilibrium. So that's our first question here. Then if we move on to the next slide, which doesn't want to happen yet, but let's get there. Almost there, almost, almost there. Oh, okay, come on. Let's try that one more time. Sorry. Why? Thought we were somewhere. Okay. Oh, there we go. Okay, sorry about that delay. I'll try and take it out. This next question is about understanding the equilibrium constant. And the biggest thing here is you do not include solids. And then for the equilibrium constant, it's always your products over your reactants, and the coefficients you see become the exponent. So in this question, you would have Kc equals the concentration of CO2 to the power of 3 divided by the concentration of CO to the power of 3. And again, we're not including these two because they're solid. So the one that we'd have here, this answer is C. This shouldn't have been there. All right, so that's our next one. When we look at this question number 3, we have a bunch of information, and it's giving us some initial conditions. So what that means is this is going to be an ICE question. So whenever you're given initial conditions, you do want your balanced chemical equation. And here we're making NO, so just make sure it's balanced by putting a 2. It tells you it's equilibrium, so you want the arrow in both directions. I'm being lazy, so I didn't include my gas state, but we know it's all gases, so it all is included. Then you set up ICE. Initially, if there are 10 moles of N2 and O2 in the system, and your initial is all about concentrations, so you'll take 10 and divide it by 50, and you get 0.2 moles per liter for each of these. And unless it tells you otherwise, products you can assume are 0 initially, unless it tells you otherwise. Then your change is all on the mole ratio. So concentration is directly related how it's going to change, whether it's increasing or decreasing based on that mole ratio. So that change, you can say it's X, but here N2 has a 1 in front. So we would say minus X because reactants get used up, and O2 minus X. And then the NO products get formed. So we're going to add 2X. Then when it comes to equilibrium, you add your column. So this will be 0.2 minus X, 0.2 minus X, and then this would just be 2X. Now, when it asks you to calculate the equilibrium concentration of NO, that means we have to solve for X. Now, we can do that because we know the Kc value. So I'm going to write this in here. Kc is 650. And then the Kc is products, so NO2, which is going to be 2X squared, divided by reactants, which is going to be N2 times O2. So these values here at equilibrium, but because they're multiplied by each other, I'm just going to write it down one time and then square it because there was 2 of them. Now we want to solve. So to solve for X, because that would be our next step, you want to square root both sides. So you have the root of 650 equals 2X divided by 0.2 minus X. Now here you're just going to do the math. We're going to get X alone. So we'll have, I'm just going to go over here and I'm going to run out of room. The root of 650 times 0.2 minus X equals 2X. Then we'll have to distribute that root 650 through. I'm just going to put that into my calculator. and you get 25.49, and that value keeps going. So don't round too early. Take the root of 650, multiply it by 0.2, and you get 5.099, and that number keeps going, minus the root of 650x equals 2x. Then we want to move this value to the other side, collect all your x's. So I'm going to add the root of 650x, and that goes away. So now on my right hand side, I'll do the root of 650 plus 2 gives you 27.495, and that number keeps going and it belongs with x. And then you have 5.049, and that number kept going. Actually, was that supposed to be 99? I think it was. Let me just double check it. 0.2. Yep, that was a 9. All right, so now we'll take 27.495, because we want x alone, and divide it on over to the other side. Sorry, excuse me. So 5.099, again, I want that number in my calculator, divided by 27.495, and I don't want to round too early. And I'm getting the value 0.185, and this number keeps going. And that's what x equals. Sorry again. So now I go back to the question, and it's just asking the equilibrium concentration of NO. So I would take a look at my equilibrium column of my ice chart. My NO is just 2x. So I take the number I found, multiply it by 2, and you're going to get that 0.37. So again, this was an old diploma question. The column here should have been A, B, C, D. But that's how we solve. Set up ice, use your equilibrium column in the K.C.E. expression, solve for x, and then go back to the equilibrium column, or row, sorry, to figure out what you are asked. And now this last question, which again was a quiz question that I gave, it's a nice easy question. You just want to know the K.C.E. expression, or the KEQ. Again, we can keep all our states because they're all gases. I'm sorry. And set up the expression. So H2 to the power 3 times CO divided by water times methane. And there's no exponents because those all have the coefficient of 1 in front. Once you have that, then you do some replacing. Substitute the value for hydrogen in, so 2.10, and this is to the power 3. CO is 5.45, and then the denominator, water, is 7.94, and methane is 2.97. Now we can plug that all in, and I will do that right now because I don't have it written down. So 2.10 to the power 3 times that by 5.45 divided by, I'm going to keep the bottom in brackets, 7.94 times 2.97. And keeping 3 sig digs, you should get 2.14. So I hope you find that helpful. If you have any questions, please leave me a comment. If you do find it helpful, please like and subscribe. Thank you.